In this video, we're going to talk about the confidence procedure. When you finish watching this video, you should be able to describe what the confidence procedure is, know when to use the confidence procedure, describe the purpose of the confidence procedure, and be able to apply the confidence procedure. Let's start by reviewing what we mean by the maximum capability of a scale, or ruler, or any measuring tool. Now, if we ask a typical person to make a measurement of the mass of whatever's on this 3 being balanced, they're going to say 348.5 grams. If we put a different object on the exact same scale, they might say here 552.6, and it's a little bit past the 662 grams. And not really consider that these measurements were made with any different quality, any different capability. But in fact, they communicate very different things. Not only do they communicate a different mass, but they communicate a different confidence in your measurement. This one communicates confidence down to the tenths. This one communicates confidence down to the hundredths of a gram. And in fact, both of these are the same scale, so they both ought to have confidence to the same level. So this student should have recorded a 50 here rather than just a 0.5, a 0.50, communicating that they are confident that it is 0 of the way between that line and the next line. Now, let's go on and look at a measurement of something else here. Here's a rounded table, a rounded box or something that we're going to measure with the centimeter ruler. Now, the maximum capability of this ruler maximum capability here is going to be ones, tenths, and in between is hundredths, so hundredths of a centimeter. Alright, but now let's ask 3 people to make these measurements. The first person looks at this and says, well, that's pretty close to the outer edge there. We're going to call that 3.39 centimeters. The second person measures and says that's right about there, 3.31 centimeters. And a third person measures and says, gosh, that's not even quite to there. I'm going to say 3.27 centimeters. All right, well, we have those 3 people make that measurement, and we want to know, well, what is the true value of the width of that? Well, of course, we can't ever know the true value because all we're doing is measuring, but and each time we measure, we get a slightly different number, it looks like. But what we can do is approximate that true value with an average of these 3. And the average of these 3 comes out to be 3.30 centimeters. But now when we look at this, there's a lot of variability. No variability in the ones place. Some variability in the tens, and a lot of variability down in the tenths and the hundredths place. In other words, we might not really be as confident as the maximum capability. We might not really be as confident that it is that our measurement is good down to the hundredths of a centimeter because there's so much variability there. And in a good experiment, variability does not inspire confidence. Reliability, repeatability inspires a confidence in your measurement. All right, so repeatability inspires confidence in your measurement. Here we don't have very much repeatability in the hundredths place. So perhaps our maximum capability rule is not really the right rule to determine what we should write down. Again, we want to write down a number that we're confident in. And since the maximum capability seems to give us too much variability or unrepeatability, we would like to have a different technique to record our measurement. And in part 2, I'm going to introduce the confidence procedure as a way to make sure that the number we write down is repeatable and that we have confidence in our measurement.